Hello, today I will present our work, HyperDreamBooth. Hyper Networks for Fast Personalization of Text-to-Image Models. This presentation has been designed by Nathaniel Ruiz, and this is work with talented collaborators at Google. Our work operates in the context of the subject-driven generation problem. Specifically, DreamBooth allows for learning a subject and reproducing it in different contexts and with different semantic modifications. One of the applications that DreamBooth unlocked were AI selfies that you might have seen in the wild. Two main problems of DreamBooth are that the model size is large and that it takes a relatively long time to train. We propose HyperDreamBooth in order to alleviate these constraints. Using only one input image, HyperDreamBooth personalizes a model in 20 seconds. 25 times faster than DreamBooth and 125 times faster than textual inversion. The model is also 100 kilobytes, which is 100 times smaller than a vanilla DreamBooth model. Our contributions are as follows. Lightweight DreamBooth LIDB, a personalized text-to-image model where the customized part is roughly 100 kilobytes of size. This is 1,000 times smaller than a vanilla DB model and 10 times smaller than a LoRa model. A hypernetwork that leverages the LIDB and generates weights for a given subject, which provide a strong directional initialization that allows us to quickly fine-tune the model in order to achieve strong subject fidelity within a few iterations. And finally, we propose rank-relaxed fine-tuning, where the rank of a LoRa DreamBooth model is relaxed during optimization in order to achieve higher subject fidelity. Our work acts in two steps. First, we generate a weight space prediction using the trained hypernetwork, and then we perform quick fine-tuning in order to faithfully learn the more intricate details of a person's face. The two-step process yields high-quality, personalized models with a fraction of the training time. Here we show, for different references, initial outputs before any intervention, initial hypernetwork predictions, and results for our full method using the hypernetwork and fast fine-tuning. In order to have a smaller weight space such that the hypernetwork can predict the personalized weights more easily, we introduce lightweight DreamBooth, which is a further downsampling of a LoRa DreamBooth model. Specifically, we propose to randomly initialize and lock down and up auxiliary layers and only train two projections, downtrain and uptrain. In this way, we reduce the number of variables the hypernetwork needs to predict from 386,000 to 28,000. The hypernetwork is trained on a dataset of cropped faces with a diffusion denoising loss and a weight regularization L2 loss, where the ground truth weights are pre-computed using DreamBooth. During fast fine-tuning, the hypernetwork first predicts an initial set of weights for the diffusion model, and then these weights are further fine-tuned in the same way as DreamBooth does, except we reach strong results much quicker. The hypernetwork structure is that of a transformer with a visual transformer encoder backbone that predicts a face embedding. This face embedding is then fed to a transformer decoder that ultimately predicts embeddings that will become diffusion model weights using k iterations of residual forward passes. Here are some results for our method, exhibiting very strong performance for stylized generation of personalized portraits. Our method preserves the existing styles of the model, which allows for very strong editability compared to other fast personalization methods that vastly change the model and bias the distribution. Our model performs on par or better than DreamBooth for the task of personalized portraits and strongly outperforms textual inversion. Note that our method is at least 25 times faster than these variants. In a head-to-head user study, our method outperforms DreamBooth and E4T for user preference with respect to personalized user stylizations with identity preservation. For more quantitative results, please join our poster session or check out our paper. Our work has received strong reception from the community, and we hope it helps pave the way for new ideas and faster personalization methods for image generation and beyond. We encourage everyone to pursue this very interesting and fruitful work.